a very important question and a very good question based on current density. This is a class 12th topic of electricity. The question says, the current density in a cylindrical wire of radius is given 2.0 mm is uniform across a cross section of wire. That means the current density that is J is given uniform. The cross and the value of current density J is given how much? 2 into 10 to the power 5 ampere per meter square. What is the current through the outer portion of the wire between the radial distance r by 2 and r? That is, we need to calculate the value of current. That is, let us suppose this is r, the outer radius is r, the inner radius is r by 2, and we need to calculate the current through this cross section. Says in this case it is already given that the current density is uniform and the value is given 2 cross 10 to the power 5 ampere per meter square. What we have to do, we have to first calculate the area of the remaining portion. This rig type area we have to calculate, and let us suppose we denote it with A net, that is equals to what? That will be equals to area of this section, that is area for capital radius r minus area for capital R by 2 का radius का हमें area निकाल लेना होगा. And we all know this is nothing but a circle, so this is what? Pi r square minus pi r square by 4. So we are left with 3 by 4 pi r square, and easily we can put the value of r here in this equation. So we are getting A net as what? 3 by 4 pi r square, that turns out to be 3 by 4 into pi is nothing but 22 by 7. R was given how much? R was given 2 mm. For meter it turns out to be 0.0020 per square in meters. If we calculate this, we'll get some value about 9.424 into 9.424 into 10 to the power minus 6 meter square. This is what is the net area that we have, that is equals to 9.424 into 10 to the power minus 6 meter square. So now what we have to calculate is we have to calculate the current through that area. That means if in this case we have to calculate the current passing through this area where J was uniform. So we know current, we can write I as equals to, I will be equals to integration of J vector dot dA vector. Now dA vector here is already uniform cross section we have, that is current density is uniform, so yeah, हो जाएगा A vector. Again they are in a same direction, that turns out to be again integration of JA vector dot A vector. जब हो जाएगा तो इंटीग्रेशन साइन लगाने की जरूरत ही नहीं है, cos वहाँ पे सिंपल 0 होके 1 हो जाएगा. So we are left with what? J, that is the current density that is already given. I guess the value is given how much? It is given 2 into 10 to the power 5. Area we have calculated, that is 9.424 into 10 to the power minus 6 ampere per meter square and cancel out. So we are left with the value of current, that is, I guess it is around 1.9 amperes approx. 1.9 amperes approx for this section when the current density was uniform. But let us take a case. When we have a current density. In second case, the current density J is not uniform. It varies with some radial function, that is J will be equals to some radial function is given, that is J is equals to AR square. It is given J is equals to AR square, and the value of A is given, that is equals to 3 into 10 to the power 11 ampere per meter square. This is given 3 into 10 to the power 11 ampere per meter square. It is given. Now we have to calculate this area first of all, where J is not uniform. So we can easily see this is again R, this is R by 2. When the current density is not uniform, it is changely with radial function. That is, for every change in radius, there will be the change in the current density. So what we can do, we can simply take a element here, a ring-like structure. So what we can do here, let us take it to be of here of radius r, thickness is dr. The thickness here is dr, and if we calculate the area, that is here we have to calculate the area of this particular ring-like structure that we have. So area will be what? dA. Why I am writing d, derivative of a, because it is getting changed with respect to every change in r, that is dr. So it will be nothing but what? 2 pi r dr. That means for every change in dr, there will be a change in the area section, dA. Isn't it? Yes or no? Again, we know the current formula, that is I will be equals to integration of j vector dot dA vector that we have. And we can easily see they both are in the same direction. That means after opening this bracket, I get what? Mod of dA, mod of j, mod of dA, cos 0. Cos 0 again turns out to be 1. Isn't it? Yes or no? Now if we calculate this, I can rub this out. The I will be equals to integration of what? J we have a r square, area we have 2 pi r of dr. 2 pi r of dr. And what is the limit here? That means from r by 2, from this area to this area. That is from r by 2 to r. Now if we calculate this, I will be equals to a is constant. We can take it out. 2 pi is also constant. 2 pi a. So we are left out with what? R by 2 r. We are left out here with r cube dr. Isn't it? 2 pi a. We can take common. R by 2 r cube dr. Now after integration, what we get? After integration we get I is equals to 2 pi a r to the power 4 by 4. Lower limit is r by 2, upper limit is r. So I will be equals to 2 pi a. Here we are getting r to the power 4 by 4 minus r by 2 to the power 4 by 4. We can take it out common. 4 we can take it out common. It will be much more easy for us to calculate. It will be nothing but what? R to the power 4 minus r square to the power 4. If you put out the values here, I will be what? 2 pi is nothing but 3.14. You can take 2 by 22 by 7 also. Area was given. The value of A was given, that is A 3 into 10 to the power 11. Please mind this unit, A by m square by 4. Here we can write it out at R is what? R was already given 2 point something was given, 2 meter or something. So we can write it as what? R to the power 4 minus r to the power 4 by 16. We calculated, it will be left out with what? 15 r to the power 4 by 16. And r we all know it was given around 2 mm. 2 mm it was given, and in meter it was what? 0. We can put r here, 0.0020 in meters. R we can put here what? 0 point, because it was given 2 meters. 2 mm. So in meters we can cancel it out as what? 0.0020 meters. So approx value that we will get in this case is 7.1 amperes. So we have to consider all these cases, and we have to double check the question that whether it is given is a uniform current density we have, or we have non-uniform current density. So in this case it was a non-uniform current density, because for every change in R there was change in the current density J. So in this case we have to solve like taking the integration, and we have to take the element and then we have to solve.